All right, in this video, we'll go ahead and balance the redox reaction, but in this example, we'll balance the redox reaction in a basic solution. Now, we have been doing examples in an acidic solution. So what we're going to do now is balance the redox reaction in a basic solution, and you'll see that the steps are very similar. There's just a couple things that we need to add at the end. So we're going to follow the same procedures as balancing in an acidic solution, and then we're going to add a couple of steps because in a basic solution there's going to be hydroxide present, so that's going to play a role in our balancing. Okay, so there are two other videos on balancing in acidic solutions, so I'll refer you to those on some of the details. So allow me to just kind of go through the motions here and go ahead and balance this. So we're going to use the half reaction method. This methanol species, carbon, hydrogen, oxygen, is related to this formaldehyde species, CH2O. I'm going to give myself some space because I might have to add some things in there. The second reaction is the dichromate. And the chromium ion. Okay, so have your rules in front of you so you can follow along. On the first half reaction, let me balance the atoms other than oxygen and hydrogen. So one carbon and one carbon, so those are already balanced. Next, I'll balance the oxygen using water. There's one oxygen here, one oxygen here, and so those are already balanced. Now let's balance the hydrogen using H+. Let's count 4 hydrogen here and 2 hydrogen here. So we'll balance with 2 H+ to make that a 4. Okay, so the carbons are balanced, oxygens are balanced, hydrogens are balanced. That should be aqueous. Now let's balance the electrons, or the charges, I'm sorry. So over here there's 0 charge, this is neutral. This molecule's neutral. There's 2 positive charges here, so remember we always go to the higher charge. This side has 2 positive charges, this side has 0 charge. So we're going to add 2 electrons to balance out the charges. Okay, let's go to the second half reaction. Let's balance the chromium. There's 2 chromium here and 1 here. So this is a 2 chromium 3+. Let's balance the oxygen. 7 oxygen here. So on the product side, we'll add water, liquid, and we have to do this 7 times. So 7 times 1 oxygen, that gives us 7 oxygens. By adding the water 7 times, that's going to give us more hydrogen. So there are 14 hydrogen here. We need to go back and balance hydrogen with H+. And the last thing we'll do is balance the charges. Now here on the product side, you'll notice water is neutral. So right here you've got your 2 times 3, 2 moles of chromium. So the total charge over here is a +6. On the reactant side, you've got 14 hydrogen, that's 14 positive charges, and then you have 1 mole of the 2 negative for dichromate, so that's going to give us +12. Okay, so we want the charges to balance. We obviously have too many positive charges here, so we're going to add electrons to the reactant side to balance those charges. So 12 positive, and we're going to put in 6 negative charges. That's going to give us our +6. Okay, so at this point, all of the atoms and charges are balanced for the half reactions, but what we have to do now is put these reactions together. Before we do that, take a look at those electrons. This doesn't make sense. There are 2 electrons being lost by the methanol. There are 6 electrons being gained by the dichromate. So we need those electrons to balance. So clearly what we'll do here is we'll multiply the first equation by 3. So let me do that down here just to clean this up a little bit. Or let me rewrite everything. 3 methanol (3 CH2O), 6 hydrogen, and the 6 electrons. And down here we'll have the dichromate, (14 hydrogen), 6 electrons, 2 chromium, and 7 water. Whoops, sorry about that. Got everything in the picture now. Okay, so let me pick that up, that way we don't get confused. So this is the new balanced half reaction. So clearly the electrons cancel. Something we saw in the last example, there are a couple of other things that cancel here. Well, actually one other thing, you notice there's some hydrogens here. 14 hydrogens on the reactant side, 6 hydrogens on the product side on these different half reactions. So 6 hydrogens here will cancel with 6 hydrogens here. So the net is 8 hydrogen. So I'm going to rewrite this. So let me add the half reactions. 3 methanol, a dichromate, the 8 hydrogen, three of this CH2O, 2 chromium, and 7 water. And I'm just barely going to fit it in here. Okay, so at this point, we've completed the acidic solution process, balancing in an acidic solution. But we go back up here, our question was to balance in a basic solution. And so if you look at your notes, follow along in your notes, we've got 2 extra steps here. So in a basic solutions, that means that you're going to have hydroxide in solution. And so there's a consequence here. The hydroxide will react with that H plus. So if you follow your steps, we're going to add 8 hydroxide to neutralize whatever hydrogen is in our net reaction. So 8 hydrogen get neutralized by 8 hydroxide. We got to do the same thing to the other side. So on the product side, we'll also add 8 hydroxide. Now, what's the consequence here? 8 hydroxide and 8 hydrogens give us 8 water. That's part of the neutralization. So we're going to have another one of these canceling out to do, because now, because of the hydroxide, we've got the 8 waters. We've got 7 waters on the product side. So as you can imagine, 7 waters here will cancel 7 waters here. And the net is 1 water. So again, let me rewrite this. Here's my final balanced equation. The CH3OH aqueous, there's 3 moles of that. We still have our 1 mole of the dichromate. We had the 8 hydrogens, but they were neutralized by the 8 hydroxide to give us 8 water. Of those 8 waters, 7 were canceled because we had 7 waters on our product side, so they canceled 7 waters over here. There's 1 water left over. And on the product side, we have our 3 CH2O, our 2 chromium, and our 8 hydroxide. So you notice in the basic solution, you should always have those hydroxides remaining. You should not have any hydrogens remaining, because remember, the hydroxide in a basic solution will neutralize those hydrogens.